A tiny drop of blood in the shape of a circle with spines that show the direction of travel. Satellite splatter is a drop that breaks off from the parent drop. In this pattern, artificial blood is obtained with a medicine dropper by dropping to a bond paper sheet on a slightly rounded surface. We inject the blood by repeatedly dropping it in. As can be observed in the image, both the satellites and the droplets have visible spines. Blood pools are a type of bloodstain that don't have a distinct shape but show that a lot of blood accumulated on one particular substrate. To create the appearance of blood pools, we took synthetic blood, pour it into a plastic bottle, and pour it into a bond paper, as shown in the image. The blood is flowing widely and there are a few spots where blood splatters are visible. A bloodstain pattern formed. When a drip stain source moves from one location to another, we take some artificial blood and set it on a piece of bond paper. We use a medicine dropper to apply the blood, and we do so in a way that makes it appear as the bloodied person is moving in a different direction. In addition, we identify its point of origin and direction. A pattern of bloodstains left behind. After a large amount of blood is forced out under pressure, like in a spray or spurt. Furthermore, using a brush squirting artificial blood to the bond paper, we ensure that it resembles a teardrop-shaped creation with tails arranged in a parallel fashion. Resembling a spurt also, we identify its point of origin and direction. When a wet, bloody object comes contact with a surface may be used to identify an object or body part. Transfer bloodstains may reveal information about the direction and movement of individuals at a crime scene, or provide evidence of contact between objects and individuals. They are important in forensic analysis for reconstructing events and determining factors such as the position of victims or suspects in relation to each other and the scene. There are two types of transfer or contact bloodstain pattern: the wipe bloodstain pattern and the swipe bloodstain pattern. To clarify, we demonstrated what a transfer or contact bloodstain is by using the swipe bloodstain pattern, in which we applied synthetic blood to one of our members' palm and he used the blood-stained hand to make a mark in the white bond paper. Furthermore, to identify the wiped bloodstain pattern, We applied artificial blood on one of our members' palm and dabbed it onto the uneven wall surface to create a trace that he was unaware that he had left a bloodstain pattern behind. Swipe pattern of bloodstain pattern, resulting from the transfer of blood from a blood-bearing surface onto another surface, with characteristics that indicate relative motion between the two surfaces. Transfer stain of bloodstain resulting from contact between a blood-bearing surface and another surface. Wipe pattern, when an unstained object moves through a bloody surface or an existing blood stain, the resulting pattern is called a wipe pattern. Upon placing the bond paper above the rough concrete, we dropped artificial blood at once. In addition, as can be seen in the image, there are spines, parent drops, and satellite spatters. Satellite spatters are the tiny blood droplets that separate from the parent drop as soon as they come into contact with the surface. Parent drop, a droplet that is the source of a satellite splatter. In a rough surface, same process we used from the smooth surface by our observation. The parent drop is not a circular in shape, unlike to the normal drop in a smooth surface. There is only few spatters, and also we observed that in a moment that we dropped the blood in the rough surface. In a smooth surface, we dropped in an instant a 100 milliliters of synthetic blood-busing medicine dropper with the height of 5 feet where we drop it. As what we can observe, there is many spatters scattered around the pool center. To determine the direction of the blood drop, in a smooth surface we threw a 100 milliliters synthetic blood to two direction. Second, we find and measure the parent drop and the satellite spatter, which we measure its length and width through caliper and ruler, and we mark each measurement as what we can see in the picture. By computing the angle of its origin, we use the formula sin -1 width, length in order to get the angle of impact. We threw synthetic blood 2 meters away from us. In measurement, we used a ruler and protractor to measure the length and the angle of the bloodstain. Also, we got documentation to ensure accurate recording of observations, measurements, and findings, reducing the risk of errors in analysis. Record the measurements accurately, noting units of measurement, e.g., millimeters or centimeters. Furthermore, we took photographs and videos of the stain from various angles for documentation and analysis. To find the angle of impact of the bloodstain, we determined the direction to identify the direction from which the blood impacted the surface by examining the shape of the stain. We applied the string method by placing pieces of strings at the edge of the bloodstain, following its long axis. Extend the string in the direction of the blood's origin. The stringing method involves placing a piece of string along the long axis of a bloodstain to determine its directionality, helping us establish the angle of impact and the origin of the blood. This technique is valuable in reconstructing the events leading to the formation of the bloodstains and providing insight into the dynamics of the incident. Moreover, to identify the measurement of the angle between the string and the surface, using a protractor can be used to measure the angle of impact off bloodstains. Once the directionality of the bloodstain has been established using methods like the stringing method, a protractor can be placed on the surface near the stain to measure the angle between the surface and the direction of blood travel. What is the importance of point of convergence? The point of convergence is essential in bloodstain pattern analysis for several reasons. Determining the origin, it helps identify the area and space from which the bloodstains originated, providing insights into the location of the blood source. Reconstructing events, by establishing the point of convergence, analysts can reconstruct the sequence of events at the crime scene, including the direction and angle of impact of blood spatter. Understanding dynamics. It aids in understanding the dynamics of the incident that produced the bloodstains. such as the position of individuals involved, the weapon used, or the force applied. Providing evidence. The information derived from the point of convergence serves as crucial evidence in forensic investigations and legal proceedings, helping to establish timelines and corroborate witness testimonies. In addition, the point of convergence plays a pivotal role in piecing together the story of a crime scene and aiding in the pursuit of justice. As we ended this video, our observation during our activity is that blood is important in gathering evidence in a crime scene. However, it is not that easy, because we should measure the accuracy of its measurement, in angle of impact, its area of convergence, the point of origin, its unique characteristics of each blood patterns.